Okay, hi everyone. Today we're working with solving a system of equations using elimination. So remember, that's our third method of solving a system of equations. The first one was graphing. Then we learned how to use substitution. And now we are using elimination. And hopefully you found elimination to be pretty easy. I see in IXL that over half you guys finished it and with 90 to 100. So great job. So we're going to use those skills now with these word problems. And I'm going to try to convince you that these aren't that hard. We just have to believe in ourselves and spend time doing it. Okay, so here we go. Write a system of equations to describe the situation below. Solve using elimination and fill in the blanks. Okay, we're going to solve using elimination and we're going to answer the question. In order to burn calories and lose weight, Irma is trying to incorporate more exercise into her busy schedule. She has several short exercise DVDs she can complete at home. Last week, she burned a total of 601 calories by doing 4 body sculpting workouts and 5 yoga sessions. Okay. This week, she completes 1 body sculpting and 2 yogas and burns a total of 208 calories. How many calories does each workout burn? So we know that we're adding up the calories. So the first one is we have 4, we'll use B for body videos, and 5 for yoga, and we'll use Y for yoga. And this gives us 601 calories. So what are we doing here? We're saying, hey, each of these videos burns so many calories. The yoga videos burn so many calories. And if I watch enough of them, I should add up to 601. Now, how much does each video burn? So she's completing each of these videos and they're going to help her lose some weight. Well, I don't know how much each of these videos are. How many calories does a body sculpting video burn? I don't know. How many calories does yoga video burn? I don't know. And that's what synthetic division allows us to help us do. It helps us to find those missing variables. We know parts of the answer. We know she did 4 and 5 videos, and we know that they added up to 601. Now, since we have 2 variables, we need 2 equations. Here's our second equation. She did 1 body video as well as 2 yoga videos. And this burned 208 calories. Okay, great. Now, looking at this problem now, how do we solve using a system of equations? So to use a system of equations, the goal is to add downward, and do we see, does anything cancel out right away? It doesn't. So since it doesn't cancel right away, we have to say this is a level 2 problem, and can we change one of these variables to cancel out the other? Can I change a 2 to become a 5, or can I change a 1 to become a 4? I think 1 to become a 4 will be a lot easier. So let's go and do our level 2 problem. And we're going to change the second equation. So I'm going to write this in red so you guys can see. I'm going to change this guy to a 4 by multiplying both sides by 4. And not only a 4, but a negative 4. And why did I choose a negative 4? Because I want to cancel out the b's. Here we go. So we could rewrite this equation. Here we go. We're going to rewrite it as negative 4 times b is 4b. Negative 4 times 2 is a negative 8y, and 4 times 208 is negative 832. Okay, because 4 times 200 is 800 and 4 times 8 is 32. Okay, now we're going to combine these 2 equations now. If you remember in synthetic division, we combine these 2. We're going to add these 2 down. If you want to rewrite this on the side, folks, if you want to write 4b plus 5y equals to 601 and negative 4b minus 8y equals to negative 832, please feel free to, because this is a lot more obvious to see, hey, the 4's now cancel out. We could do that. But I want to save you time. I want to convince you this isn't a lot of work. So that's why I'm not rewriting it. So let's go ahead and use the 4 and the negative 4. Those cancel out. Those eliminate. 5 minus 8 is negative 3y. And 832 and 601, they eliminate, they subtract out to become negative 231. 231, yes. All right, our next step is to solve for y. Let's go ahead and divide both sides by negative 3. Mr. Ko, I don't like dividing. I don't care about your whining. Okay, so here we go. I'm going to teach you guys the fast way of division. Okay, if you guys haven't learned how to divide using fractions, how many times does 2 go into 3? Nope, Doesn't, right? It's too small. So we move it up. How many times does 2 go into 23? 2 goes into 23. Y is equal to 7 times. Okay. 3 goes into 23. 7 times. Remainder 2. 3 goes into 21. 7 times. That's 77. Turns out 3 times 77 is 231. So we are saying that for yoga, each yoga video will burn 77 calories. Now that we found the yoga videos, let's go ahead and plug in to solve for the body sculpting. Now, to do this, we talked about it before. We just plug it into any other function. So now I'm running out of space here. I'm going to squeeze it over here. So do you want to use the top equation or the first or second equation? It's up to you. I see that the second equation might be a little easier. So let's go ahead and use that. 1b plus 2y. We said y was 77. Oops, other way around. Y was 77. And this equals to 208. And when we solve for this, hey, neato, b plus 154 is equal to 208. We're going to minus 154 from both sides. B is equal to 54, I think. 54. Yep, 54. Okay, because 208 minus 154 is 54. So we have solved for our body workout videos, body sculpting videos, and our yoga. The body sculpting videos are going to burn 54 calories, and the yoga is going to burn 77. Now, we have to double check. You don't have to, but you know IXL, if you put like one wrong number, you have to start all over again. So I'm going to double check, and you can use a calculator for this. If I say 4 body sculpting videos at 54 calories each, plus 5 yoga videos at 77 calories each, does this add up to 601? Now, I'm going to use a calculator here. That's fine. You guys can use a calculator for this simple math stuff. Oh, sorry. I'm trying to look for my calculator. It's going to be 4 times 54 plus 5 times 77. And we do end up with 601. We do. 4 times 54 is 216. And 5 times 77 is 385. And they do add up to 601. And again, I use my calculator to check this. All right, let's go ahead and plug this in to make sure. 54 and 77. So 54 and 77 for the yoga. All right, let's see if this works. All right. Whew. That was stressful. And take a look here. Where already jumped to 20. Your goal is to get to 70. All right. Our goal is to get to 70 today. All right, let's do our next problem. This one has a lot larger numbers, but let's not let that intimidate us too much. So our goal is to read the paragraph, write our equations from it, and then we can use a method to solve it. In this case, we'll use elimination. All right, Jeremy plans to have, Jeremy and Emma are hosting events that are catered by the same company. Jeremy plans to have 77 adults, use the letter A for adults, and 99 children to attend. So the projected cost for his meals is $4,796. That's not too bad, actually. Emma has 50 adults and 55 children on her guest list, so she will pay the caterers $2,975. Okay. Okay. All right. So we take a look at this problem now, and we see, can I eliminate anything? Is there anything here for elimination? Is there anything here for elimination? And what I'm noticing is that I can't make 50 look like 77, and I can't make 7 look like 50. So let's go ahead and try our best here. and we're going to change some stuff around. We're going to make the 50 look like 77 and the 70 look like 50 by just multiplying them together. Okay. But here's actually another one I've actually noticed. Now that's the obvious choice, but I'm going to actually give you guys another choice. If you look at the 99, is that 9 times 11? And is 55 5 times 11? Now this is me just going above and beyond here. I could again multiply them by 77 and 50 here. I could have done that. But instead, know what? I'm going to multiply by smaller numbers. Because they both share an 11, hey, I just need to multiply the top by 5. And if I multiply the bottom by 9, we would actually end up with the same number. So let's go ahead and do that. I'm going to need a calculator here to multiply these numbers out. These are kind of big. I'm hoping that the numbers that you get will be a little smaller. I'm looking at some other problems, and it seems like they should be a little smaller. But here we go. 55 times 77 is 300. So I'm going to rewrite these numbers over here. 385 A plus 99 times 5 is 495 C is equal to 5 times 4796. This is a huge number, but I'm using a calculator, so it helps me a lot. I'm going to multiply the next number by 9. 50 by 9 is 450 A plus. Now, here's my problem. Remember how we mentioned we have to cancel them out? If I multiply the bottom just by 9, will they cancel out? Turns out they won't. So I'm going to multiply it by a negative. So luckily I caught it, and it's okay to forget about it, but you got to catch yourself. Put negative 55 times 9. Guess what? It's going to be 495, right? Just like what we wanted, because we want them to cancel out. Oops. 495 C is equal to, and I want to multiply this by 9, 2,975. 2,975 times 9 is 26,775. And I'm going to put a negative there. Sure, these numbers look big, but where did I get these numbers? From a calculator. So using elimination, we're going to add down now. Add down and see what we end up with. So 450 minus 385 is going to give us 66 adults. That's going to be negative still. The children cancel out, and we're left with 26775 minus 23980. This is going to be negative 2,795. Oh, wait, what? Did I make a mistake someplace? Let me pause. Sorry, it wasn't 56, it was 65. It was 65 here. That was a 5, folks. I'm sorry. 65. So 2,795 divided by 65. Oh, darn it, what? Okay, never mind, it's going to work. So A, we're going to divide both sides by negative 65. Negative 65. Again, I'm doing this on my calculator. A is equal to positive 43. So the adult meals are $43. I would never have guessed that in my entire life. But we have this method of elimination where I could make them look like each other, make the variables look like each other by multiplying. And then if those go away, we can solve for our single variable. Now we're going to go back and solve for the other variable, our C value, and let's use the second one. 50A plus 55C equals to 2975. We're going to use this one, but lucky for us, we already know what our A value is, right? We said our A value is going to be 43. So 50 times 43, that's our adult price, plus 55C is equal to 29. Most of this time I'm just copying the problem. 50 times 43 is a huge number. That's $2,000, 2,150 plus 55C. And again, we're just using skills from day 1 class, okay? We're going to minus 2150 from both sides, minus 2150. So 2975 minus 2150. We end up with a positive 825. We can divide this by 55. So our C value, our children's cost is $15 per meal. They're probably having chicken nuggets or something. So the idea is that we could take this huge problem, we can run exactly the same steps we had practiced before on our other elimination problems in IXL, and we can use that to solve this system. And it would say, hey, it would cost adults $43 and it costs the children $15. If I want to double check, if I plug in 77 times $43 plus 99 times $15, does that give us our 4,796? Again, I'm going to use my calculator to double check this. 77 times 43 is 3,311, and 99 times 15 is 1,485. And do they add up together to become 4,796? They do. This does become 4,796. So we have double checked and we found that we can find the values of each of these meals in this crazy complicated situation. Now, here's the starting part. Let me ask you this part when we first started. Was it hard to write these equations to start? Was it hard for me to say, hey, there are 77 adults and 99 children. So we're multiplying 77 adults by the adult price and 99 children by the children price. So we get a projected meal cost of, right? So I want you guys to encourage you guys to make sure you guys do try these, because word problems start by just trying it. You just got to try it. If you guys aren't sure how to write an equation, try it, take a picture of it, and then ask me, hey, Mr. Ko, does this make sense? That is totally fine. Okay, we have 43 and 15. Let's go ahead and plug that in and see how we did. It says it's going to be 43 and 15. Now remember, if you hit the wrong thing, if you hit submit and it's the wrong answer, it's okay. But make sure you do look at the suggestions of what you got wrong and how their equation might have been different from your equation. Okay, wow. They really are giving you the harder ones here. Let me go ahead and trying it again. Look for some easier ones. Nope, it's going to be just as hard. Okay, so we'll do another, let's say, we'll do 3 more of these questions and then we'll call it a day, okay? So I'll do 3 more of these just so we have a nice range of questions. Okay, Anita and her friend Pamela are each baking apple pies and tarts for the bake sale. Using the same recipe, Anita bakes 1 apple pie, so 1 apple pie, and 4, let's use P instead, because we have pies and tarts, are both apples. 1 pie and 4 tarts, and this becomes, you need 31 apples. Okay, Pamela made 6 pies and 10 tarts and used 102 apples. All right, so hopefully you guys are not terribly shocked at how difficult this is to translate from a word problem to an equation here. Now, what does P and T stand for? P and T stand for the number of apples required. I need so many apples to make a pie. I need so many apples to make a tart. Now, can I make the 1 look like a 6 or the 4 look like a 10, or do I need to change them both? I think I can make the 1 look like a 6, right? So I'm going to multiply them by, I'm going to change the top equation by multiplying both sides by a 6. But in this case, I can't use the regular 6. I need a negative 6 because I don't want them to just combine. I want them to cancel. Positive 6 and negative 6. Positive 6 and negative 6. Right, if I'm going to rewrite it. Now, folks, I mean, I'm going to show you this. And this will save you even more time. You guys are ready for this? Instead of rewriting the whole question down here, I'm just going to write the number on top. What is 6 times 1? That is negative 6. We have negative 6p. Negative 6 times 4, that's negative 24. And 6 times 31 is negative 186. If you take a look here, I don't even rewrite it anymore. I'm just writing the numbers right on top to save me time. Why? Because take a look. 6p and 6, those cancel out. I can save myself time if I really wanted to. Negative 24 and positive 10. That's negative 14t. Oh, 14t. Negative 186 minus 102 is negative 84. Okay. Let's go ahead and divide both sides by negative 14. And that's going to be t is equal to 6. So it takes me 6 apples to make the tarts. Okay, that is t for tarts. How many apples does it take me to make a pie? I don't know. Let's use the equation. 1p plus 4 times 6, because t we said was 6 already. That saved ourselves some time. 31. P plus 24 equals to 31. That's minus 24 to both sides because we're solving for p. P is equal to 6 plus 1 is 7. 7. Take 7 apples to make pies. If you want to double check, we can plug into my second equation. 6 times 7, because that's how many apples it takes to make a pie, plus 10 times 6, because it takes me 6 apples to make a tart. This is equal to 102. I don't know, but I sure do have a calculator. This is 42 plus 60. It does add up to 102. Just to double check. Why are we happy? Because we got some pie going on. Pie. Anyone ever make apple pie before? We have 7 and we have 6. Yeah? It tastes so much better than when you buy it, right? Homemade apple pie is so much yummier. Oh, okay. I need to focus on this question because I just saw a couple keywords here. I'm not sure if you guys saw these keywords in this problem. I'm getting kind of a little what? I'm seeing some keywords. I'm seeing all you can eat. Okay, I'm seeing some keywords here. All you can eat and sushi. Okay, two things that Okay, I see all you can eat and sushi. I need to focus on this problem. Oh my goodness, all you can eat sushi. When's the last time you guys had all you can eat sushi? Trudy is a server at an all you can eat sushi restaurant. I feel sorry for Trudy. At one table, the customer ordered 3 children buffets. Okay, so I'm gonna use C for child and 2 adult buffets. Man, this problem speaks to my heart. And the total is only $76. What in the world? This is some grade D sushi. Oh, you don't like sushi? Well, you don't like California rolls either? At another table, the customer ordered 4 children buffets and 3 adults, and they paid $108. Okay. I didn't like eating raw fish when I was younger either. Now, only when I got a little older did I more appreciate it. Okay, here we go. Now, if you can see here, I can't make 3 look like 4. I can't make 2 look like 3, can I? So, but we can make them look like similar numbers, and it's up to you. I can make them both look like 12, right? Or I can make them both look like 6. 2 times 3 is 6. I can make them both look like 6. Or 3 times 4, I can make them both look like 12. It's up to you. I'm going to choose A just because they're smaller. Just because the only reason is because I'm going to become smaller. So to make 2 look like 3, no, to make 2 look like 6, so the goal is I want to make this guy look like 6. So I need to multiply the top by 3. Let me use a different color here. I'm sorry. Multiply the top by 3 and the bottom by 2. And if I do that, 3 times 2 is 6. 2 times 3 is 6. They'll both be 6. But I need one of them to cancel. I need, fishkin. Fried fishkin? Oh, yes. Darn it. Why are you guys talking about food? Oh, sorry, that's my fault. The all-you-can-eat sushi. Okay. So we need to make one of them negative because we need them to cancel. Now you make a choice. Do you want to make the top negative or bottom negative? I'm going to do a little trick. I say, hey, isn't this 9 and this is 12? I'd rather have negatives be smaller. So I'm going to actually make the top negative again. I want the negatives to be smaller because then my answer will be positive and I don't have to make a mistake with negative signs. So I chose the top to be negative. So we can rewrite the problem as negative 9c minus 6a equals to negative 21 plus 18 is 228. Okay, you could do that, and you can rewrite it over here. This is going to be 8c plus 6a equals to 216. We could do that, write them separately on the right, or I could be lazy about it and just write it on top. This is negative 9, this is negative 6, and this is 21 plus 18 is 228. See, you can just write it on top. Exact same idea here. I just wrote it on top to save me a little bit of time. 8, 6, and 216. Again, we could write it out, which is perfectly fine, or just write them in small little notations. Now, both ways will give us the same answer. 9, negative 9. Oh, this is 12. Darn it, I thought it was 12. Negative 9 and 8 give me a negative c. Oh, darn it. This is negative c equals to, those subtracted become negative 12. Whoops, I should have made the bottom negative. I don't know what I was thinking. What if I did the work over here? This would still be negative c equals to negative 12. Same exact work. But I think we would save time just writing the little notations. Now, the thing is, on your work for the test, I better see some type of work going on. If I don't see the work, you won't get the credit. Simple as that. No work, no credit. This is like a math rule from the beginning of time. No work, no credit. I don't want to see magic answers. Divide by negative 1, divide by negative 1. Or you could just flip it. C is equal to 12. The answer here is C will also equal to 12. So you pick one way. You guys can rewrite it, make it look nice and official. Or you just write the notation on top, especially on a test since you're saving time. I consider this all work. If you do that, I will give you full credit because that's the work. Now, what's the adult price? I don't know. Let's go plug it back in. 3C plus 2 adults, which is $12 each, equal to $76. 3C plus 24 equals to 76. Now, you have to write minus 24 to both sides. You have to write that. 3C equals to, now you can use a calculator if you want. From this point, 52, then we can divide both sides by 3. You still have to show the steps, though you can write, you can do the 52 divided by 3 by a calculator. C is equal to 1, that's 3, that's 20, wait, whoops, we can't divide that, I miscalculated. This is 50, is that right, 50? A is 24. Oh, shoot, 24, 52. I can't divide it by 3. Give me a second. I made a quick mistake someplace. Okay, so I made a mistake, and it's a typical mistake. I plugged in the wrong variable, and thank you for people in the class pointing that out. My goodness. Oh, Mr. Co. Wait, that part was right. This part's wrong. If you see here, I solved for C, but why, Mr. Co? Why did you plug into A? Because we said sushi and we said all you can eat, and Mr. Co's brain just stopped working. Oh, darn distance, darn COVID. Mr. Co would be in a buffet now because of this problem. Okay, thank you for catching that, everyone. 36 plus 2a equals to 76 minus 36 to both sides. Thanks for catching that. 2a equals to, that's going to be 40. Divided by 2, divided by 2. A would be 20. It would cost $20 per adults. So just to double check that, if we said it costs 4 children is $12 and 3 adults, which is $20, would that add up to 108? That's 48 plus 60, and that does add up to 108. Just to double check. Okay. All right. Okay. So I think this is a good place to stop off. Our problems pretty much are all like this. So as you guys work through these problems, please work on setting it up and then finding a way using elimination to get rid of one of our variables, in this case the a, and solve for the remaining variable. Once we solve for that remaining variable, we can plug it back into any of the original questions, original problems, so that we can find the other variable. And that's how we solve for word problems, a system of equations with elimination. Okay, thank you very much.